So can I ask you guys, when we take the derivative of each of these functions, wouldn't we expect these, because they're all signed, to give us the same derivative out? Mark is shaking his head no, so why do you think no?
Close to, sorry. And so, and the other one, you bring it down to the two, because if you have the 2 in front of the sign, it's not the same thing as having 2 after.
Okay, yeah, so we can kind of see that if we try to use maybe some of our previous derivative knowledge, that these probably aren't giving us the same things. Zainab? Yeah. Okay, so if we look at trig identities, we can kind of see that these are equal to different things. These are also, like, if we change a function, even if it's what's inside that function, or if we square it, we get actual different equation, like we get different graphs. So if I have a different graph of an equation, then of course it's going to have different slopes of the tangents than a regular graph of sine x. So we should expect that all of these types of functions would give us different derivatives. So no, oops. So we'll say these are all different graphs. Causing the tangents to have a variety of slopes, right? They're all going to have the slopes of the tangents changing differently, with different slopes and all of that kind of stuff. Okay, the only time where we could kind of say that, like, 2 different equations could actually have the same derivative is when that equation essentially has parallel tangent slopes. So only equations, I'm going to give you an example. Only equations where the slopes of the tangents are parallel will have the same derivative. So if we think about the graph of sine x, and the graph of sine x plus 1. So we already know some information, of course, about the derivative of a constant. The derivative of a constant is 0. But if we think about the actual graphs of these functions, sine x is kind of like the one where we are along the midline, and it looks like that. That's like one cycle of the regular sine graph. When I add 1, I'm technically taking that and I'm shifting it all up 1. So if I have tangents along my red graph here, they're actually going to be parallel to the tangents on my black graph. So for instance, here for both of them, they both have tangents that have parallel slopes. Okay, same thing here. If I draw the tangent here, I'm seeing that the tangent at that, or I guess it's not quite at that x value there, be at like here. Okay, that tangent also has like a parallel slope to my other one here. So because the slopes of the tangents are parallel on these functions, they actually end up having the same derivative because the tangents change at the same rate and the tangents are the same slopes at the same points. So we kind of already know that just by looking at sine x and sine x plus 1, just based on the information that we have. Of course, we know the derivative of sine x is cos x, and then the derivative of this, we take the derivative of sine x, which is cos x, and the derivative of 1, which is 0. So of course, those are going to be the same, even though they're different functions and different graphs. Question? No? Okay, so I want you guys to take a couple seconds and see if you guys can predict the slopes or the derivatives of these 4 functions. See what you can figure out. Work with a partner. So somebody tell me what they put for the derivative of the first one here. Any guesses out there? Mark? Ooh, very good. Okay, so it's kind of like a chain rule thing. We do the derivative of the outside. So we get the cos of 2x, but we also have to multiply it by the derivative of the inside. So we actually end up multiplying it by 2. So we get 2 cos 2x. Okay, good. So we're going to do a little bit more practice with that guy today. Guesses for the second one? Mark? Okay, so how did you get that? Okay, so it's kind of like power rule, right? So we do the derivative and then we kind of like subtract 1. Very good. So kind of when we well, actually, you know what would be a good thing for us to do is think about this as if it's, oops, let's do that. There we go. Let's think about this as if it were sine x squared. Do you still agree with your final derivative, Mark? Okay, do you guys agree? Is this 2 cos x? Olivia? We agree? Okay, so it's kind of like chain rule, right? So you're right in the sense that we use power rule on the outside. But I'm going to subtract 1 from that, and then I'm going to multiply it by the derivative of the inside, right? So totally chain rule, exactly what chain rule is there. So we do outside using power rule times derivative of the inside. Trust yourself. Okay, third one, guesses? That was the second one. Vanessa? Yep, sure. Devin? Agreed? Mark says no. It's close. Okay, what's the derivative of the whole thing? So the derivative of sine we know to be cos. So we will get that part back. So we will get the cos of x squared back. And then we need to do the derivative of the inside of that, right? 2x, very good, yeah. So that's not inside the cosine though, right? This is like the cos of this whole thing times 2x. Very nice. Good, okay. And the last one, this one's an interesting one. Mark? Agreed? So this is a product. So we have to use product rule, okay? So my first, maybe I'll do this just below a little bit. So this will be my first right here, the x squared, and this will be my second, right? So we are going to do, for the last one, derivative of the first, which is 2x, times the second, plus the first, times the derivative of the second, which is cos x. So I think we can kind of drop some of these brackets here. So it's 2x sine x, and then x squared cos x. And that's it. Okay, so we're going to do a little bit more practice with these today. Olivia? Yeah, so I didn't quite simplify that. We can just do this. 2 sine x cos x. Like so. Okay, so we're just going to do practice with this today, just so we can understand how to apply these rules. So chain rule. Think of it as we want to do derivative of the outside, so we do derivative of the whole thing, right, like the cos part, and then we have to do derivative of whatever is inside the cosine. So thoughts as to what the derivative for this guy will be? Okay, yeah, so we get negative sine of 3x, so this is kind of like the derivative of the outside kind of thing. And then we want to multiply this whole thing by the derivative of the inside. So the derivative of 3x is 3. So when we simplify this, we'll just get negative 3 sine of 3x. Okay, yesterday we learned about the constant multiple rule. So when I have a constant multiple, I can kind of just take the derivative of that second part and then leave the constant multiple out. So f prime at x, thoughts on this one? Mark? Okay, so not cos, oh, okay, yeah, there we go, good. Okay, so derivative of the outside, so we're doing derivative of this part, the derivative of sine is cos, times the derivative of the inside, so derivative of the inside is pi, so we'll have 2 pi cos pi x. Mark? Yep. So I like to think about it like this, because then we kind of remember that it's like an outside inside kind of thing. So this is a chain rule type thing where we do power rule. So we bring this down and subtract 1 from the exponent. But then I also have to multiply it by the derivative of the inside. Yeah. Well, sine squared x. So the only reason why we write sine squared x instead of sine x squared is because this can be a little bit confusing sometimes, and people don't necessarily indicate brackets on where the squared is. Is the squared on the x or is the squared on the entire sine? So this is actually equal to this, right? But we write it like this so that we don't confuse it with this. Yeah, but these two things are the same. Yeah, good question. Okay. So this is kind of the same idea when we say cos cubed x. This is what Mark was just asking about. Really what we're saying, it might be helpful to think of it as this, right? Cos x times itself 3 times, right? So we're going to use power rule, and then also we have to do kind of like a chain rule thing. So the first part, when I take the derivative, is I want to bring down the 3 and subtract 1 from the exponent. And then I also want to multiply by the derivative of the inside. So this is the outside. And I want to do the inside. So what should I get for the second part? Negative sine x, good. So I think we can just rewrite this little, just simplify it a little bit to negative 3 cos squared x. Usually that's how we would write it. And then it will be times sine x. So that's kind of how we would usually write it. Olivia? So it's when we think of like cos squared, we're thinking cos times cos. So it's just like the square of the whole thing, not the square of the inside of that. If it were x cos x, then I would apply it to the cosine and also the x in the front that's being multiplied. Yeah. Mark. So a cubed only applies to what's directly in front of it. So it's only applying to the sine part of that. Yeah. So if we think about it like this, that can be helpful. So constant multiple rule, we just take the derivative of that second part there and multiply it. So we get 6 sine x all squared times the derivative of the inside, which is cos x, minus, and then I'm bringing the 2 down, and I'm subtracting 1 from the exponent, so I just have cos x, and then times the derivative of the inside, which is negative sine x. Okay, so let's simplify a little bit here. And sometimes when we common factor things from here, we might be able to see something that can be simplified using a trig identity or something like that. So we usually just try, if we can, to maybe common factor and see what happens with that. Sometimes it won't get us anywhere, sometimes it might. So I see a common 2 and a common sine in each term. And I don't really think that there's much that we can do with that. There's no like trig identities that I see that. Oh, sorry, and we have a common cos, of course. And I can't erase. Sorry. Common sine x, cos x. Oh, now I see a trig identity. Get your trig identity sheets, people. This right here is a double angle identity. Pardon? Yeah, we're just simplifying. So this is actually the sine of 2x right here. And before you ask, yes, if you can use a trig identity to simplify, we will try to do that. Oh, yeah. I was just, because I already had, like my first term had sine x cos x, I was just writing it in a similar way, but it doesn't really matter now. Yeah. I took a 2 out. So when I common factored 2 out of the 8, I had 4 left. Okay, that one was fun. Right?
Yeah.
Sure. Okay, let's move. Why can I not scroll now? Okay, there we go. Okay, couple more. So here I'm differentiating with respect to t. So what we would kind of put for our derivative notation, yes, you can use y prime or dy over dt. I want to use product rule here. So think of this as your first and think of this as your second. Okay, so we want to do derivative of the first times the second plus the first times the derivative of the second. And then I'm just going to common factor out the t squared. Any questions for that one? Okay, so think of this guy as your first for the next one, and then the second part as your second. We're gonna have to do some chain rule stuff here too, so maybe we want to rewrite this before we start as times the cos of t squared, just so we can remember derivative of outside times derivative of inside. And then I'm going to start differentiating. So we're going to do the derivative of the first, which is sine of 4t. So we'll get 4 cos 4t. So derivative of the outside, and then I'm multiplying it by 4 because that's the derivative of the inside, times the second, which we can just write as cos squared t, plus the first, exactly as it is. And I'm seeing that I'm going to run out of room here already. Times the derivative of the second. So we need to do a chain rule type thing here, Zainab, yeah. So derivative of the outside is just the cos of 4t, but then I need to multiply it by the derivative of the inside, which is 4t. So what's the derivative of 4t? That's what we're just talking about. So when I have sine of 4t, what's the derivative of sine? But then I need to do the derivative of this interior part, which is what? Times 4. So I put the 4 over here, okay? Okay, so the first times the derivative of the second. So I have to do kind of like a power rule and chain rule type thing here. So I do 2 cos t times the derivative of the inside, which is negative sine t. Sorry, that should be obviously on this line right here. Okay, so here's what we've got. Sorry, I'm just going to rewrite this out on the same line for you guys here. Oh, I should put the 2 out front as well. The 2 is here and the negative is here. Okay, common things here. I think we can take out a 2 cos t. And then we are left with 2 cos 4t. And then cos t minus sine 4t sine t. What trig identity? 2 sine t cos t. Yeah, we could. Wonder what I did last year. Let's see. We common, oh no, that's not the same one. Yeah, we just common factored last time. You could do a. All right, so you guys are gonna try this one now. See if you can differentiate this bad boy. That's just a challenge.